let's move to our next speaker, Michael Cook, and he'll tell us about the relocation and expansion of his observatory. Go ahead, Michael.
Okay, well, good evening, everybody. Just want to say thanks to Paul for reaching out to me, asking me to present to you. He asked me quite a while ago, but I said, oh no, I'm in the middle of building something, so I had to put it off for over a year. But here we are tonight, so I'm finally glad to be able to be here. First time presenting virtually to you guys, so let's give it a go. I've been a member with the RSC since 1975, mostly as a life member, and I'm basically going to cover the relocation as well as reassembly of my two observatories from Newcastle to an area in North Port Hope rural area. If it sounds confusing, it will all come clear to you in the following slides. So the presentation will also show how I consolidated my dome observatory with the roll-off roof observatories into one structure. So some of you may have been to Newcastle Observatory that are watching tonight, I'm not sure. This is in Newcastle. It's about an hour east of Toronto, just off the 401. And Paul Markov reminded me that I presented in person at the March 2006 Toronto Centre meeting. I totally forgot about that, but I still can't remember. I have those seniors moments now. But anyway, we bought this house in 2004 and immediately placed the dome on it as a third floor space. The observatory was in operation for 15 years. So on this third floor, you have the dome, where I got an unobstructed 360-degree field of view because there were no other buildings taller than 2 stories in the vicinity. And just off the dome, there's a control room, just off the dome floor. And one could, if you're sitting at the control room desk, you could actually see the telescope in action through the window that you see there. The dome housed a Meade 40 centimeter on a Mathis fork mount. And my main observational activity is CCD photometry of variable stars, primarily the cataclysmic and Myra types. And I work mostly in the V band, but I've also dabbled with B, R, and I. All the observations are performed autonomously using astronomer's control panel. And you can see the interface here. It's usually accessible just using your web browser. I can access the dome and all the controls and everything else anywhere on the planet as long as I have an internet connection. I submit my observations to the AAVSO and the Center for Backyard Astrophysics. I also recently joined the Global Supernova Search Team, but being with my observatories in a bit of a disarray right now, I have yet to make any contributions to those guys. So my data has been used in numerous times in astronomical journals. I've co-authored about a dozen papers or so and appeared in the likes of Astrophysical Journal and similar periodicals. Here's just an example of an 8-hour of time series photometry for a cataclysmic variable called OV-BOO. It's generally a pulsating white dwarf in a binary system with a period of about 66 minutes. And you can see how the CCD camera can actually pick up the fluctuations in magnitude. These are about 1 to 2 minute exposures. So getting back to the observatory, well, that was just about what I do, about myself and what I do. Let's get back to the observatories now. So in the summer of 2020, I added a roll-off roof observatory in the backyard in Newcastle. Just recall now, this is the summer of 2020. And it was built to accommodate 4 piers with a telescope at each pier. And the objective is to have simultaneous photometric observations of different targets with obviously 4 different telescopes, in addition to the one that's in the dome. And the structure was assembled primarily with screws and bolts. The walls are all modular sections. And the whole idea here was we knew we were going to be moving in about 3 to 5 years. So that's movable. And fortunately, or fortunately, depending on who you are, that day came as soon as the observatory was completed in September of 2020. just as the crazy housing market was beginning to ramp up. So my wife and I decided that, let's get going here. We decided our next move would be better now, or it's going to be never. So the only one to mention in this one here slide here was note the low ceiling of the roll-off roof. And that's because I wanted to keep the structure as low as possible in the backyard. The backyard wasn't exactly a large space, so I wanted to keep the scale sort of in keeping with the backyard. But I'm glad we moved because I was able to remedy that situation, and you'll see that in the following slides. So here we go with the move. In October 2020, we made our move from Newcastle, shown right here by the Newcastle, Ontario here, red flag, out to an area north of Port Hope. It's about a 25-minute drive from our previous residence. It's a much better location. A light pollution map showing Newcastle Village here. Bortle scale, I think, is like 6, something like 5 or 6, and this area in North Port Hope now is about 4, probably a little better than 4. But the other advantage is there's no local light pollution in the form of street lights or neighborhood lights from adjoining houses because all the houses are far apart. So here's the property. It's situated 168 meters high up in the Northumberland Hills. It's about 2.5 acres. The area at the back, third, was chosen as the location of the observatory. The trees block the light from the surrounding properties, not that there is any really. Here's the concept for the observatory consolidation. So at the right is the original dome. In the middle, we connected by a control room, a warm room as well. And to the left is the reassembled roll-off roof observatory. Note that I added a short wall to the roll-off roof observatory to eliminate any roof scope collisions. The bottom of the diagram, you can see the configuration of the 4 piers. It's shown inside the roll-off roof observatory. And the observatory is oriented in an east-west direction. So this is the backwoods where the observatory would go, just beyond the 5 blue spruce trees. I should say that parts of the disassembled dome and observatory and the roll-off roof observatory, all those parts were sat in my garage, one of my garages, for the whole winter, winter of 2020, 2021. Because we had to do some significant renovations to the house. I just didn't have time to put all this together in the late fall of 2020. No time for astronomy. But starting May 1st in 2021, we started some land clearing, hired a company to do that. Took out about 100 trees. They chipped all the trees in sight. The trees wasn't too sad to see them go because they were Scotch pine. They're not even indigenous to Canada. Even the birds don't like them. And really thinned out. The woods weren't managed very well. A few days later, May 3rd, began excavation for the location we're going to put the observatory. That being for the concrete slab that the observatory is going to sit on. So we hired a family-run company that did the excavation and concrete work. They were quite fantastic workers. After the excavation and minor leveling, the 4 pier forms for the roll-off roof observatory and the dome pier were set in place. These are witch's hat PVC concrete forms. As well, a quantity of aggregate was placed and leveled as a substrate for the concrete slab pour. May 4th, the cement truck arrives, and this is the first day it arrived to do just the pour, or the concrete pour for the piers. They had to be shoveled into each pier form by hand. And then while still freshly poured, we had these plywood jigs that hold the bolt pattern for the steel piers. And these bolts were embedded into the concrete to receive the steel piers later on. The same day, the form for the concrete slab was installed. Here's just a close-up of the jig for the bolt pattern for the piers. These are 1-inch bolts, 120 degrees apart. So after allowing the concrete piers to set and cure for a few days, the crew returned to pour the concrete slab. As you can see, the slab is reinforced with steel mesh. It was ended up being a good pour. They floated the concrete. I didn't require an ultra nice finish because it was going to be a floor in here anyway, so they just did like mostly a rough float. And here we have the finished pour. Note the dome pier in the foreground is offset to the south to accommodate the equatorial tilt of the fork-mounted telescope. This offset enables the telescope tube to be centered in the dome when pointed at the zenith. Also, there's a gap in between the piers and the slab, just to make sure that I don't introduce any vibrations from the slab to the piers themselves. Also, while the excavator was around, we had them dig a trench from the observatory location all the way back to the house, and that was to bring power and data cables. The power cable is a direct burial armored tech cable, the black cable on the right in the right picture. And while the data cables are run through conduit, the gray tubing you see there, there are Ethernet and coax cables in that conduit. So here's the finished slab ready to receive the building, and the surrounding property was properly graded for drainage as well. And I was advised to wait a couple weeks to let the concrete cure well enough before construction of the building. So that didn't start until 22 days later, about 3 weeks. So May 29th, construction starts. I should mention that the whole thing was built by me alone, moi, because of this silly thing called COVID going around. So it was quite a challenge. So I started the dome end of the structure, did that first, since it was the simplest to build, just a square building. And that way I could get the dome parts out of the garage, free up space in the garage to do other work in there as well. So after a week, the dome building was completed and the dome installed. And it would take me another 6 weeks for the roll-off roof observatory and control room to be basically completed. I started with reassembling the roll-off roof base walls shown here. Easy enough because, like I mentioned, the wall sections were modular and they just bolted together. I should mention that the entire structure is bolted to concrete slab as well. With the roll-off roof base framed, work on the roll-off roof itself could begin. And here are the bogies that carry the roll-off roof on its tracks. Each bogie has 3 6-inch V-grooved roller-bearing industrial casters. You can see them here. There's 3 of them in this bogie. Each bogie has a capacity, each caster has a capacity of about 500 kilos. So there was 6 wheels in all. Gives you 3,000 kilos of capacity for weight bearing. I did estimate the roof to have a mass of about 1,000 kilos, so there's lots of tolerance to count for carrying the roof as well as for snow load. And boy, did we ever get a lot of snow lately. Everything about this construction had to be managed as a one-person effort. Winches, leverage, and a strong back were my friends. With the bogies in place, the roll-off roof short wall framing could be built. Recall this was a new feature of the roof, so that way the roof trusses would clear the scopes at all times, regardless of the telescope orientation. Here the roll-off roof trusses and the rest of the framing is complete on Canada Day, but not totally complete. There was on the underside of the roof, I had to do some added stiffening here. You can see a little bit over here. Let me just, if I get this here, pen, that one there, there we go. Right here, I made these plywood gussets to stiffen the structure between the short wall and the trusses. To complete the enclosure, I reinstalled the steel roofing that I had purchased. This is a and shingles was initially chosen a couple of years ago. So so I could disassemble the entire structure as was originally planned. So the steel shingles are held on with, they're all interlocking. It's a great product, very easy to put on and take off, make quite quick work about it. And there we have the entire structure enclosed and weather tight. The next day, work what I call the roll-off roof trestles. The first thing was to reinstall the roll-off roof rail beams. There's a couple sitting off the back of the Jeep right there. These had to be, there's two that run from the roll-off roof building to the west of the plane. Each has to be level, perfectly level, and perfectly parallel so that the roof can be easily open and closed with not too much effort and without any binding. So here's the finished trestle with lots of cross bracing to ensure support and rigidity for the 1,000-kilo roof. And there we have the roof open. I'd like to point out that the Meteor CAM there's a Meteor CAM on the mast right there. And there are actually now 3 cams pointing at different sky locations, and these cams are part of the global Meteor network. Here's a more recent shot showing a new mast for the Meteor CAMs. I should mention that these cams are controlled using Raspberry Pi computers, pretty nifty stuff. Here's just one snapshot of a night's work of Meteor CAMs. That was taken on January 26th. And you get quite a few dozens of meteors every night. It's pretty amazing stuff. Back to the construction, both the control room floor and the roll-off roof observatory floor have moisture membranes and are heavily insulated. So you get nice, warm, toasty feet when you're out there. Each steel pier in the roll-off roof observatory is bolted to the concrete in-ground piers via a flange and 3 1-inch bolts. The control room, shown in the distance, is provided with a window to monitor scope activities. And with the floors insulated, I was able to add some outdoor carpet as well. This view is from the control room. 2 telescopes have been installed to date. There's a Takahashi 150 shown in the background, very nice instrument. And in the foreground, there's an 8-inch Celestron Edge that I'm currently hosting for someone else. I also installed smart controlled LED lighting so that you can select from a full spectrum of lighting from white to any color you basically want. That's a great little addition. You can actually say, hey, Google, turn on the red lights, and away she goes. The dome scope has yet to be installed, but that should be happening this month. Here's the entrance to and from the dome to the control room, and there are 3 steps up to the dome floor from the control room. This is the new pier for the 40-centimeter Meade on its fork mount. Since the dome building is 8 feet tall, the pier had to be, it's a brand new pier, had to be taller for the scope to clear the dome slit. This new pier is pushing 200 kilos, and it's going to take some effort to get into place. Let's see what else here. The roof right now, I was opening it manually, but I recently installed a motor to open and close the roof. It's basically from a gadget or a mechanism used to open sliding gates. It's a rack and pinion drive. The rack is along the observatory wall there, and the motor containing the pinion is at the far end. And basically, when you hit a button for a remote control, it can open the roof in quite quick fashion. I think it's 8 inches per second. It takes like 30 seconds to open the roof. And this whole thing will be automated with third-party equipment in a few months. This is just a video. I hope it's coming through for you guys. It looks like it is. Shows the first test of the roof motor in action, and yeah, it works pretty well. So I'm quite happy with that. So there you have it. I just wanted to mention that a heat pump was installed as well to the observatory. This gives me air conditioning in the summer and heating in the wintertime. It's a great, although expensive, it's a very efficient way to heat and cool a space. I don't even notice this thing on my electrical bill. It's quite something. And it even provides heat during those, minus 25-degree nights that we had not too long ago. Yeah, so I'm about to wrap up here. So if I was presenting in person, I would have brought a stack of these moon phase calendars for you to each and every one of you. But if you head over to my website, you can download it there under the download section, and right there. But you can also reach me at this website, newcastleobservatory.ca. And I just thank you for your attention. And if you have any questions, I'll try to answer them.
Michael, thank you so much for sharing this with all of us. That's an impressive facilities you've built. And what's even more impressive are your carpenter skills. Well done. Let's go to Emma. Do we have any questions for Michael?
Yes, we have a couple of questions. First one coming in from Ralph. Did you have any problems with zoning or permits to put up the new observatory complex?
No, because the property being a sufficiently large property, I mentioned like 2.5 acres, lots of room for outbuildings. Everybody in this rural subdivision here has outbuildings even larger than mine. So the only thing I needed to get was a building permit.
Very nice. And Paul Markov wants to know, where did you source the piers from?
Oh, I had the piers are my own design, and I just drew up some plans for them. They're pretty basic. I mean, it's just a steel tube with a flange welded to the bottom and a top piece welded to the top, and then you just have to specify the bolt hole pattern and any bolt holes or center taps for anything you want to attach to the top of it. And I just brought this to a metal fabrication company in Bowmanville, and they turn that around. They turn on these piers like in a couple weeks.
Very cool. Thank you. That's all the questions.
Fabulous. Thanks again, Michael. We'll have you back in the future, perhaps, and you can tell us a bit about the observations you make with all the equipment there.